This is recording, sorry.
Started. So I'm Shai. I'm a postdoc here in the Integrative Biology and Physiology department. So my office is unfortunately right across this door. So that's kind of convenient. So today I am going to be telling you a little bit of Python. Okay, so before we get started, did you all get the slides I just made you, the slides slash the notebook? Were you all able to open it? Okay, that's great. So, this will be a little bit of an experimental kind of programming course because, as you might know, there is this new thing called ChatGPT, which is able to code really, really well. So, I want to try and see how well we can actually like use it to build more interesting stuff rather than just learning some, syntax of a language. So let me just tell you brief before I go into more detail. How many of you had experience with programming? Maybe not Python, but programming at least. No, okay, two people. Okay, that's great. So this is the right workshop for you then. So, but you might have to believe me a little bit on some of the things I'll tell you. Okay, so the way I learned programming is I started with this language called C++. Okay, so the way it worked during those days, so this was more than a decade ago. So the way it worked was you had this fat a textbook, okay, and you just went through each and every syntax of the programming language. You learned how to give computer instructions. There were a bunch of instructions that you just had to memorize and you fed them into the computer. You practiced how to use them, how to concatenate a bunch of them, and then you made computer do things that you wanted it to do. Okay, so that was how people did it. Okay, but then came this revolution, which is Python. Okay, so what is really so special about Python? Well, the idea is this is what's called a high level language. Okay, so it kind of abstracts away what's happening below with the computer and the hardware, what's going underneath. And what it gives you is all these high level functions where you can almost talk like in natural language and make it do certain things. Okay. So that's what we are going to try to do, especially with the advent of AI. So what we are going to try is we will mostly use cloud resources. So that's Google Colab. So let me show you Google Colab here. So this is Google Colab. It just requires you to have a Gmail account. Does everyone have a Gmail account? Okay, so I suggest you log into collab.google.com. Okay, so the reason I suggest this is because let me show you the nice features that are available here. So here, if you see my screen, it says start coding or generate with AI. And here is a nice small box which asks you, what can I help you with? Okay. So let me show you how I code these days. Okay. Let's say I want to create two objects, shark and tuna, and initialize their X, Y, and Z coordinates. Okay, so usually this works really well. So as you can see, what it did is this really nice piece of code. Okay. And that is all coming purely from what I just wrote here. I want to create two objects, shark and tuna, and initialize their X, Y, and Z coordinates. Okay. And one thing I want to mention, this might not be very obvious to you if you haven't coded before, is not only is this code correct, it's also very well, very nicely written as well. Like this is almost like production level code. So here, for example, what's happening is it's creating this big object called an animal object. And then this animal object, what it has three coordinates. Each animal will have three coordinates, which is called X, Y, and Z. And now it's creating an animal called shark, whose coordinates are 10, 20, and 5. It's creating another animal called tuna, whose coordinates are 30, 15, and 10. And that is just coming from this line of code. So now, with the help of AI tools, the goal is not necessarily to know exactly the correct syntax, but to be able to roughly say whether this makes sense or not. Okay. And that's what we will be hoping to learn. Okay. Does that make sense? Okay. So that is the reason I suggest Colab. So I want you all to go ahead and upload the first notebook onto Colab. And I want you to be able to use this feature and essentially look at AI code and try to see if it makes sense. And we will learn from the mistakes AI makes and also from the syntax AI gives us. So I already have the AI locally on my computer, so I don't have to go to Colab. But please try to log into Colab, upload this notebook onto Colab, and if you are having any difficulty, please let me know.
Second question, if
Yes.
you're drawing anything on Python, you always have to tell them about the coordinates, initialize X, Y, Z coordinates.
Yeah, I'm actually going to get to that very soon. Yeah. So I want you to first have Colab so that you can run code that you can share, and then I'll tell you how computers work, and then we will basically slowly get there.
So within Colab, how do we pull in this particular one?
Oh, sorry. I think I should have showed you that. So you go to Colab here,
Yeah.
and then you say upload notebook here. And then whatever file I sent you, that .ipynb file, you just upload that, like right here.
This file will be automatically saved in our account, or we keep saving as we go.
So I think it automatically saves, but just to be sure, you can just keep pressing save whenever. And also, like, don't worry too much. You're not going to be doing too much stuff. So even if it doesn't save, you can always like recover your work quite easily. Yeah, let me know once you have the collab running and you have the notebook uploaded. Everyone? Oh, okay. Oh, you're doing it. Oh, and also while we wait, I would really appreciate it if you can fill in the Google form that I hopefully have in the notebook. So it's a very quick workshop pre-assessment form, basically to give me an idea of like how much you know about computers, how much you know about programming, and things like that. Very simple questions. Shouldn't take you more than 2 minutes. Does everyone have the form?
And look, is at the beginning of the page or
Let me see.
once it's green?
Always way ahead.
Oh, and way ahead.
Yeah, those are very big. Yeah, just a little below.
Like with this chapter. Yes, I'm good to that's not they're wrong. Yeah, that's the fun thing. Like site is that you ever or that has to be trained.
The collaboratory AP.
Yeah, but what which Wi-Fi? Lawyer Hall, whole long list. Yeah. The collaboration.
No, the Wi-Fi is collaboratory AP.
That's the user.
Hmm? No,
Okay, there's no cool. Nope. That's your rights.
yeah, it is called collaboratory AP. And this the main sort of thing that would be really helpful is the last question here. What is the number one thing you wish to do with Python? Because that will help me, like, especially if it is something reachable with a beginner level Python course, I might just add it to the course. I hope by now everyone has uploaded the stuff to Colab, right? Okay. And maybe you're just filling in the Google form. Okay, great. I can tell you I don't know any art, but you know what I do sometimes? I just write Python code. I give it to AI, tell it to turn it to art.
Oh, I see.
And then it turns it to art, like, and it will be like as good as a code any art person would write more. Yeah, like so sometimes what I do is Python is usually slow. So what I do is I write Python code for the whole project, and then I look at small pieces which are taking a lot of time. And C++ is usually fast. So what I do is I take that small piece of code, tell it to ChatGPT to convert to C++, it converts it into C++, and then I put all these together, and now I have fast performing code that I write in less than a day. Yeah. So I am hoping, so the hope, at least for this class, is that you will not be tied down to any language in particular. So I want you to get a general idea of how programming works. And once you have that idea, all programming languages are roughly the same. They have their own idiosyncrasies, but they're mostly the same. Okay, so I hope you had time to fill out the form and to get the collab working. If you haven't yet, please let me know. So, but let's get started now. I hope you're all excited. We are going to be doing some AI assisted learning. So let's see. So today, we are going to firstly cover some basics of computer programming and what is called the Python interpreter. And we'll also learn some basic syntax like variables and things like that. And we'll also learn some logical control statements, okay? And on day two, we will learn how to use for and while loops. If these don't make sense right now, don't worry about it. Like these are more or less English words. These will become like English words at least from next day onwards. And then we will go into something that is really specific to Python. It's these things called collections. These are actually really specific to Python. So these are what I mean by the idiosyncrasies. So these don't exist in other languages. Like, or they exist, but you have to like work a little hard to get them, and so on. And then there will be again other things which are very common to other languages as well. Okay, so let me first start. Oh, and before I go too far ahead, there are some basic logistics. So if you're taking this for credit, um, there will be some quizzes that you have to do. And also there will be a homework assignment in the very end that you do have to do. Okay. So the homework assignment is pass, no pass, and quiz. It's, I think, graded out of 10. So how much ever you get. But I wouldn't worry too much about this because this is something you're taking for learning. So I'm not going to like test you like whether you're going to be a software developer or not. Okay, so the first thing is running on Google Colab. So we are done with this. So first I want you to try this. So in Google Colab, there are two kinds of cells. Okay, so one is called a markdown cell and the other is called the code cell. So the code cell, you see this, here there is a thing called Python telling you that this is actually a code cell. And here, if I click on this cell, you'll see that it's a markdown. So markdown means that it's going to mainly have text. Text in some specific indentation, like what I have here, but it's still text. It's not some code that can run. Whereas this cell here tells you that this is a Python cell. So you can run Python code. Okay. So what I want you to do is I want you to type in Python code here, print hello world in the code cell below for you. I think you do have a code cell below. If you do not have a code cell, you can add a code cell here. So for instance, let's say I go here, I can just press on plus code here. And then I can just type in the code. Was everyone able to do this? Like print hello world, and then there should be an output saying hello world. So the reason we do this is it's just a tradition. So ever since programming languages begin, any new programming language you learn, the first thing you do is print hello world. I don't know why we do that, but it is something we do. So was everyone able to run this?
Yes.
Okay, great. So that's your first Python program. Okay, and the way you execute code I hope you kind of realize, either you press that run button on the side, or the keyboard shortcut is Shift plus Enter. This is what I usually always use. Shift and Enter, and then that will run that code cell and move on to the next cell so that you're not just at the same place. Okay, so here is where we come to the basic model of a computer. Okay, so what is a computer? Of course, a computer is what you have in front of you, right? But it has so many moving parts. Do we need to care about all this when we want to program? The answer, it turns out, is no. We have been able to abstractify it so well that now we think of a computer as having only two pieces. Okay? So, what are the two pieces? The first piece is this memory. Okay? So, imagine that you have like um, I'm forgetting the what it's called, a tape. Do you know what a tape is?
Measured.
Huh? Not the measuring tape, like a cassette,
Uh-huh.
like the
Yeah,
old timey things where you recorded things. So imagine like you have a cassette, okay? So basically, which is like a big tape, okay, and on each space you can write down something or record something, okay? So suppose you have something like that. So that is how you can think of as a memory, okay? A contiguous block of place where you can write stuff, okay? And then there's the other unit, which is called the logical unit. Okay. So what does the logical unit do? What it does is it performs operations like addition, subtraction, multiplication, comparisons. Is 5 greater than 3? 5 less than 3? Okay. So it basically performs all these logical operations. Okay. So you can think of these two pieces. Okay. So why are we breaking these two things down? Okay. So this is how the first computer was actually envisioned. So this is what we call as now the Turing computer. So when computers didn't exist and people had to think of how to make computers, the first things they realized they needed are these two things. One is memory to write down stuff. Two are logical operations that you can perform on the elements in the memory. Okay, and that is exactly what a program does. Okay, so you're gonna have stuff in memory, and then you're gonna perform operations on memory and then write them back in memory. Okay, does that make sense? So the first step to always in any programming language is initializing data. Okay, so for example, let's say you're interested in, I don't know, electronic health records. Okay, and you want to know how many you want to uh, place a record for each patient, right? So you have to go in and say, okay, I want this much space for patient one. I want this much space for patient two, this much space for patient three, and so on and so forth. Okay. And now how you do that for each programming language changes. So for instance, in Python, it's as simple as saying x equals 10. Okay, so here when you say x equals 10, what happens is you go and tell the computer, hey, go find me a spot on that big memory block you have, okay? And then put the number 10 in there, store the number 10 in there, okay? And remember where it is stored. Remember that address where you stored it. And let me use that address as x here. Okay, so whenever I want to recover that number 10, I can just ask what x is and I get back that number 10. Okay, so this is basically a way of remembering what is in the memory to carefully associate what's in the memory. Does that make sense? And now the next step is, for instance, you want to say add something. So now, for example, here what you're saying is, okay, go find where x is in the memory, add 5 to it, okay? But now store it in a new place. So here y will be what? 15, right? But this will be a new memory location. So it goes to the memory, finds x, then adds 5 to it, and stores the new result in a new memory spot labeled 1. Okay? So one really interesting thing that you can always do with computers, right? So when you say, I have erased the file from the computer, what does that mean?
We said X,
Huh?
then X, erase, erase X.
Yeah, you erase X, but do you have to really do anything to erase something? So for instance, oh sorry, go ahead.
Send that command, basic.
Yeah, it's a command, but the nice thing, right? Like because X is trying to remember that there is a place where I stored a certain value, right? Now, for instance, if I just cut off this association, I can still have that value stored in the computer, but if I have no way to go find that value, then that is basically the meaning of erasing. So, for instance, if you try to delete files from your computer, right, you will see that it's really fast. It's not because the computer is going and removing every bit it has written in your memory. What it's doing is it's just forgetting that it has written stuff there. It just thinks that, oh, I didn't write anything, that's just complete nonsense. And this is why people can also recover stuff from your hard drive sometimes. Because when you erase something, you don't actually remove it, it's all there. You just forgot that you have it. So that's what basically happens. So if you remove some variable, you just forget that you know anything about that place.
It also makes that storage place then
Available.
yeah, available for rewrite.
Exactly. So yeah, so that's a very good question. That's a very good thing, exactly. So when you write right now, you are potentially able to overwrite on top of that thing. So that's why sometimes you might actually be erasing something. Does this make sense? Okay. So I hope this is very clear for you now. So any programming language you take, the first step is you have to store the data that you will be dealing with in memory. And usually this memory is what I wrote as RAM before. So there are two kinds of memory, one the hard disk, and then there's the more local memory, which is called the RAM. And usually the program memory is stored in the RAM. So you have to first store the data in the local. So this is the temporary memory. And then you perform logical operations on this data. And then again, the result is stored back in the temporary memory, which you will finally write to the hard drive. So this is what you do with any programming language. So if you haven't done programming before, one thing that you will often see is the computers are sometimes like Amelia Bedelia. Have you seen this before? So this character, Amelia Bedelia, she is very famous for taking everything literally. Okay, so what she does, for example, is kind of shown in this. Oh, Amelia, laughed Mr. Rogers. When I said make the bed, I did not mean that. So he told her to make the bed, and she literally is starting to make the bed. All he wanted her was to put on probably the sheets and things like that. So the main takeaway is that the program will literally take your commands, okay? So if there are, for example, some edge cases or some small cases where your logic doesn't quite work, your program is bound to fail. So you do have to think about all these when you write a program. So now let's start with the data initialization and types, okay? So in Python, there are many data types that are possible. So here I just have a bunch of them. So there is the text type. So this is string. And then there are numeric types, which are int, float, complex. We will not really use that too much. And then sequence types, there's list, tuple, range, and even more things. And then there is mapping types, Boolean types, and so on. So each of these stores a different kind of object. So let me uh, show you this example first. Okay. So you should also be able to run this code. So here I have a bunch of variables that I have initialized. Okay. So here, what does this mean, right? So here there is this variable, my bool, okay, which remembers the location, which remembers the value true. True is just um, a logical value. Okay, it's something is either true or false. It's that's why it's called a Boolean variable. And then there is this integer variable which remembers the value 1000. Okay, so this when I say my int is 1000, what this really is what I said before, that there is a memory location where 1000 is stored, and this my int, this name that I have, points to that location. Okay, so that's what's really happening. Similarly, my float is 3.14159. Does anyone know what 3.14159 is? Yeah, that's fine. And then my string, which is UCLA QC Bio, you see that there's this very interesting thing that happens. It's in quotations. Okay, so all strings have to be in quotations. So these are now the idiosyncrasies of each particular language. This will not exactly be the same in other languages. And then you have things called lists where you can list things. So this is, for example, my list. You have parentheses 1, comma 2, comma 3. So this is a list of integers, and you can make it as long as you want. And this is one of the best parts about Python. Basically, it allows you to change the length of list, add elements to list, and do list operations really, really well. So these are, for example, some variables with each different data types. So what is this? So this is what is called a library. So in Python, there are many, many libraries out there. And what they do is they allow you to perform operations on the data that you have already. So operations particularly, like finding the size of an object and things like this, which most likely many people will need. So many people have already written all these functions so that we can directly use them. So this is what I'm doing here. Get size of tells me how much memory that object is occupying in the memory. Okay. So can you all try running this code? Yeah. So you should all also get this kind of an output here. Okay. So why am I showing you all this? So here you see this, right? So for example, you had this. So I had this true, true or false. Okay. So how many bits of information is true or false? So here it says it's 28 bytes, right? But how much really should it be? For example, I'm trying to ask yes or no, right? So it's either a 0 or a 1. So it's actually just one bit of information. Does this make sense? So true or false is only a bit of information actually. But you see how much Python takes? It takes 28 bytes to store it. And each byte is 8 bits. So that's 28 times 8 is how much? 224. So it's 224 times larger memory storage than it actually needs. Okay, and this is where Python is extremely inefficient. So it is taking 224 times the memory to store one bit of information, just one bit. Okay, so now let's see something even more counterintuitive. Okay, so let's take that integer 1000. Okay, so 1000 is how many bits of information roughly? It's four.
It's been a binary number.
Yeah, so you have to do 2 raised to n. It should be roughly 1000. So it's 2 raised to 10 roughly. Okay, so 2 raised to 10. So that should be roughly 10 bits of information. Okay, and 10 bits is like what, 1.25 bytes. Okay, but again, you can't have 1.25 bytes, so you'll be like, it's rough, so it should be like 2 bytes roughly. But here again, you see, memory is 28 bytes. It's 14 times more inefficient here. Okay, surprisingly, it's very efficient for float compared to integer. So even though I'm not just storing the integer part, I'm also storing what's behind in the decimal. So I'm somehow storing more information, and yet it takes lesser space. Okay, so Python does all these weird things, which you should always have in mind that these are the things that go on behind the scenes. Okay, which is one, it has a lot of what people call overhead. So you think you're storing one bit of information? No, you're not. You're sometimes storing 224 times more space. Excuse me. But that is where Python also becomes very useful, because here you saw, right? How hard was it for you to initialize? You were just like my bool equals true. That's it. You didn't have to do anything more. You just like initialized it, and Python immediately realized it's a Boolean variable, and this is the value, and I have to store this. So Python does a lot of this uh, heavy lifting for you, and that is why it takes up so much memory and everything. So another, I also want to show you this other function. So once you initialize a data type, you can also check what is the type that Python has inferred for your function, inferred for your variable. So I want you to go try running this code here. Yeah. So what you see here is very nice. So this type again is similar to the get size of function. Somebody has already written it for us, so we can just use it. So here it says, so I just put my bool equals true, and what happened was it initialized an object of the type bool, like which is what here it says, and then it stored the correct data type in it. And similarly, when I just stored my int, it immediately realized that it's an integer object, and then it stored in the class integer. And similarly, this it realized it's a float. So float is essentially the scientific way of saying decimal points. And then my list was again a class of type list. And it doesn't matter what's in the list, whether they're integers, strings, decimals, long lists, they're all same type of the class list. And this is very useful to do what is called input validation. So oftentimes what will happen is we will ask something, we will get input data from some place, and we have to check that that data is of a correct type so that we can process it correct. So one of the things that you do is what is called type checking. And this is one of the best ways to prevent like all sorts of hacking.
Is, is it like a dictionary that you can get these command links? Or, for example, how do you know to use my tag?
Mm-hmm.
Somebody could have called it, sorry, tag bomb. Somebody could have called it something else.
Yes.
Is there like a convention?
Yeah. So there is a thing where you can just type uh, help or something, but the most advanced solution is just using ChatGPT.
Yeah.
Like just ask AI and it will just give you this. And that is what I did, in fact. I don't remember because it changes from language to language and it gets a little bit annoying. So now I just want to give you a quick comparison with the different languages. Okay. So here um, we have the same command that I want to store 5. Okay. And name the storage location X in 4 different languages. And you can see Python and R are very simple. Okay. And these two will have like a lot of overhead. Whereas C++ and Java, they have a lot more. Here, for example, it says, I firstly want to create an integer type called x, and I want to store 5. Okay, so here I have to specifically tell it that I want you to store it in an integer location. Okay, here I just told store 5. Python immediately realized that it's an integer and that it needs to store it as an integer object. Whereas for C++, you have to specifically tell it. But because you specifically tell it, it reserves only 4 bytes of integer space. Okay, in C++, you can only store integers up to 2 raised to 32. So it's funny like that. So if you do 2 raised to 32 plus 1, do you know what happens?
Start again.
Yeah, you start again. So don't ever do that. But anyways, so it reserves exactly 4 bytes of integer space and puts 5 there. But compare this to what Python did before. It took 28 bytes of memory for an integer, like 1000. Whereas in C++, that same 1000 would have just taken 4 bytes. So this is extremely efficient. But the cost is you have to specify the data type. You have to be careful when the number becomes bigger. You can't just keep adding on numbers to it because once it grows beyond 2 raised to 32, it starts from the beginning again. So you need to be really careful about what you're doing. So one really useful thing that again I want to mention, especially again with the use of AI, is comments. Okay. So nowadays, when I write code, I basically don't write code. I just write comments. Okay. And the code autocomplete reads my comment and writes the code down below for me. Okay. So let me see if that will work here. So can you see what's happening? So so this is basically AI integration with my local thing. So I just wrote create and then it automatically created this whole string here. Okay, create a dictionary to hold the variables and their sizes. Okay, but this is not what I wanted to do. So I'm just going to keep writing what I wanted to do. Create a list with random integers. Okay, and you see what's happening. It's starting to prompt code here on what I should do next. So here it says import the variable, import this library called random. Makes sense. I want to create random integers. Maybe there's a library that allows me to do that, and that should be random. So I'm going to import that. Okay. Now it tells me the code to generate a random list is this next line here. And this is actually correct. So I know that because I have written this code multiple times, but this is the real advantage of using AI, which is I just write down a comment and it is able to fill in the code for me. Especially if you can break it down into many small steps, it will fill in the code very, very accurately. And I want you to try this out on your Colab. Just start writing a small, simple comment.
That's in the code or in the markdown
So this has to be in the code.
code?
Yeah.
Mine doesn't autofill. Is there a
Oh, right, right. It doesn't autofill in Colab directly. Okay, then you probably want to use the help button in the bottom. Yeah, I would just use this for now, like here. But if you're interested in how to get this autofill feature, it's actually very, very simple. You need to have this software called VS Code, which is really easy to install. Next, you need something called GitHub Copilot. If you are a student, which I think most of you are, it's free. So you can just get that for free. And even if you're not a student, it's only $4 per year. So it's not really that bad. And it gives you all these features where it will basically just fill in for you. Like nowadays, the amount of code I write is much less than the amount of code AI writes.
uh, so, no. Mine doesn't autofill on the AI mode.
Oh, really? Okay.
It, that, maybe that is, yeah,
Okay.
could be my settings on the Chrome website.
Yeah, maybe it could be that. But also, I can imagine they not giving all those features in the. And if you want to check out other IDEs, another IDE which also has these autofill features is what's called anti-gravity. It's by Google. So if you are ever interested in all these additional features, you should definitely check them out. Okay, so now we finally have the first thing you get to actually do. So what we will do is essentially we will create a list and keep adding elements to it. Okay. So first we will have a list of just zero elements like this. Okay. And then we will add an element to the list. And then we'll add one more element, third element, fourth element, and so on. And we will try to measure the size of the list in the method. Okay. And uh, do you all see the activity?
It is real mine.
Oh, really?
It, arithmetic operations after the best practice.
Maybe I switched order a
Yeah,
little
it's
bit.
further back up. You have to.
Oh, it's a little back up. Yeah, I think I switched the order a little bit.
Okay, study one.
Yeah. So please try this exercise. You're free to use AI and everything, of course. And this is not graded or anything like that. The goal is you want to keep adding elements to the list and see how the size of the list changes as you grow it, as you slowly grow it, element by element. And this is also probably a good time for a break. Okay, while we wait for some people to join us, I just wanted to show you what happens. Okay, so this is like a very brute force code that you, right? So what I wrote is I basically kept changing this my list by hand. So first I initialized it as an empty list. Okay, so just two parentheses with absolutely nothing in it, and then I printed what the size of is. Okay, and what you see is that it's 56 bytes. Okay, that's a lot of memory for holding absolutely nothing. So the next thing I did was I added one integer to it. And you see that the size of the list grew by 8 bytes to store just one. Were you able to run something like this and see stuff before?
I'm saying the F, what the F means. The F is the function.
Oh, okay. So I was actually going to get to that next. So don't worry too much about this here. So F is what is again a Python thingy. So this is what is called a formatted string. And this only occurs in Python 3.7 and above. So Python has multiple versions, and 3.7 and above has this. And it has this very nice feature where you can put in different functions inside the string. So it is just a very convenient way of printing stuff and to store stuff. And we have a whole section on this below.
Line is.
Mm-hmm.
But then they're changing the amount of
Yes.
numbers.
Yes.
Then each time it becomes a different list.
Yes.
You're rewriting on top of your list.
Yes.
I see. If I were to give different names to a
Yeah.
different list,
Mhm.
then I'm using like even
Too
more.
much space. Yeah.
Nice.
So here you're absolutely right, and that was the idea really as well, because I didn't want to use different names and different memory locations. So I'm just saying the same name. Oh, now you go and point to the list with one element. Now you go and point to the list with two elements. Now you go and point to the list with three elements, and so on. So I'm basically forgetting. So here, by the time I came to my list one, two, three,
Mhm.
these three are stored somewhere in memory, but I just don't know where they are. So this is the equivalent of erasing.
Mhm. And you can name it any way you want.
Yes.
You can call it my list, or you can call it laundry or whatever.
You can call it laundry. Oh, there are a few things you cannot call it.
Okay.
So for example, you cannot call it list equals.
Oh, okay.
Okay, so I'll show you what happens when you try to do this. So for example, you can't be like list equals. Okay, so what? So list is actually a predefined name. Okay, so there are certain names that you're not allowed to use. So list is a predefined name, int is a predefined name, bool is a predefined name. So there are these specific things that you cannot call, but anything else. My list, your list, you can call it anything. Oh, God.
Uh, is there something to signal all the numbers instead of none of them? So you put two parents, say is empty. If you want to save yourself time and say I want all the integers, is there a command for that, or a way to write them? Or
All the integers as in like really all the integers?
yeah, see, instead of the empty parentheses, is there a way or?
So there is a way to have like 1,000 integers or 10,000 integers,
Uh-huh.
but you cannot have all
Okay.
integers because you cannot store them in.
Okay,
Yeah.
I see. So it's not like at least you don't think there's somewhere else that you can.
No, no, like you cannot do infinitary operations, for
I see.
example.
Okay.
Go ahead. So that's what's called the range function. So, okay, so I want to quickly show you this. So empty list has 56 bytes. I add one, it went up to 64. Okay, starting to make sense. It's adding 8 bytes for whatever reason. Even though integer was supposed to be 28 bytes, here it only adds 8 bytes. So it's, you see, like Python does a lot of things in the background, which are very counterintuitive. Okay, so I just want to give you an idea of how much it processes in the background. You have two elements that again add 8 bytes, makes sense. Now you have the third element, it's adding 16 bytes. Okay. Now you add a fourth element, it adds nothing. Now you add a fifth element, and now again it adds 16 bytes. Sixth element, nothing. Again adds 16 bytes. So eighth element, nothing. 16 bytes, and so on. Okay. So what is going on here?
Uh, is guessing that have the same space for and it
So
knows what can you graph it, figure out.
yeah, you can graph these, right? You can graph these numbers. So what's happening is it's trying to increase by 8 bytes for every integer. But then at some point it realizes that you're going to potentially increase it even further. So for example, when you added 3 elements, it actually didn't just add space for 3 elements, it added the space for the fourth element as well. That's why when you add 4 elements, you don't need extra space because it already created a space, assuming that you might want to add it. So it does weird stuff like this, and that's why it's so inefficient. But then again, it's so fast, right? I can just write my list equals 1, 2, 3, 4. Whereas with C or C++, that would be a whole code to write. Okay, now let's come to some arithmetic operations. So these are what we will be doing all the time with our data. So addition, subtraction, multiplication, exponentiation, division, integer division, modulo, and priority. So I think most of these are very familiar to you, except maybe integer division. So integer division just means that you divide it and forget that there's a remainder. That's it. So you'll basically do the long division that you've learned in school, but you'll just forget that it has a remainder. And modulo is basically writing down the remainder. Okay? And one very interesting thing to know is here 5 is an integer, 2 is an integer, but when I divide by 2, the type changes. So here the type was integer, integer. Perform an operation, it's not going to stay always an integer. It becomes a float. Okay, so this is a useful thing to know because you might think you're always dealing with integers, but if you have divisions, things become float automatically. So next, I want you to try running this code that I have written for you here. Try pasting it in a cell and see what happens. Oh my God. Basically getting to why you have to be extremely careful in science. So, sorry for the slide maybe. Oh, okay. Yeah, I kind of rearranged them today morning, so sorry about that.
Do you want to have to run the code you wrote?
So the code I wrote should not be a code set.
No, I'll put in the code set and
Yeah, that's it, yes. Huh? Oh, not just that, the whole node. Yeah, from that. Yes, that's it. Okay. Were you all able to run the code?
yeah. So this
Yes. Everyone? Okay, good. Okay, so okay, firstly, now let's so now that you're slowly getting a hang of Python, right? Let's try to read what this code is supposed to be doing. Okay. Can you tell me what does the first line do? Huh?
is telling you that value of A
But like, let's think about like what is happening with the computer.
is creating a memory.
Correct. It's creating a memory where it's storing point one and remembering it in A.
Mhm.
This one?
A different memory.
Right. This one?
Yeah, different.
Different memory. Okay. So now what does this say? Is point one plus point two equals point three. So this is all what is called a string, okay? So this is nothing. There is no Python operation happening there. So this is just purely a string, okay? So this is where the actual logical operations are happening, okay? So here what we are asking is the truth value of the statement A plus B equal to C. So here B, you see this double equal to sign. So double equal to is actually checking equality. Okay, it is not to assign, it is to check equality. So this is really, really important. Double E. So now this value here will be a true or a false. Okay, it will be true if A plus B is in fact equal to C, and it will be false if A plus B is not equal to C. Okay, and then we are printing, again, this is all a string, and we are just printing the value of A plus B. Okay, so you should have gotten the output false, and the computer calculates something like this. Okay, so why am I showing you this? Because this is what floats do. So this is what is a classic example of what is called a floating point error. Okay, so when you're storing a decimal, there is always an error with which you will store it in a computer. Okay, even if it is one decimal point, it doesn't store it exactly like that. Like because 0.1 plus 0.2, right, should be exactly 0.3. But if you ask the computer, it's 0.30000000004. Okay, so it will always have these small errors. Okay, so that's why it's extremely important to know. So if you, for example, if you're checking in a computer, right, whether something is equal to something, you never check whether they're actually equal. because there will be a floating point error. So what you will check is, are they equal up to my tolerance error? Okay, so that is always what you have to check. So that's why this kind of a code. So actually, once we had like a Python programming class where some person, when they were writing the grading code, they wanted to check if the student answer matches the correct answer with equal to like this. And you can imagine if 0.1 plus 0.2 is not 0.3, you can imagine how different those two numbers are. And basically, all the students got zero credit because of floating point errors. So it's really important to know how much tolerance you have, and you have to check that all the floating point errors will be within that tolerance, and then check only within that tolerance.
I have a question. So I thought that when you put things in the brackets, it was just a string.
Mhm.
But to put a function inside the string, you have to use those parentheses with the.
Yes. So these parentheses here allow you to put more things.
I see.
So that's why it's called a formatted string where so here you see they are in a different color compared to
Yes.
this. So this other thing is where you can put in functions, you can do many more things there.
So if you're going to do math of some sorts,
Mhm.
and it's going to add this error, how do you know how much it's miscalculating?
Yeah, so that is actually, so you can actually more or less precisely say how much error there will be. So for example, in a floating point, I so it's 4 bytes of memory that it uses, and for 4 bytes of memory, I there is a specific error that comes with it. I'm forgetting this off the top of my head, but you know the exact amount of tolerance you can have. And that is usually how people check it.
Can you force it to give you the result to the first decimal?
Yes, you can.
That would solve the floating error problem, or still exists?
No, like even if you make it to like the first decimal or something like that, where you like it's just um, it's like how do you say, like you, because you don't have infinite amount of memory, right? Like if you don't tell the computer that it's zero point 0.3 infinitely many zeros, you just can never tell the computer it's just infinitely many zeros. It will always assume that you gave me till zero point 0.3, but there is some error which because you cannot plug in infinitely many zeros into the computer, it will just always have that error. Like here, I'm specifically telling it it's 0.3, right? Like I didn't tell it it's 0.301 or something like that. But still, when it stores it, it always allows that error.
Even if you tell it that I don't care about anything after the first decimal, is there a way? No.
So, okay.
For example, in Excel, you can tell the Excel, I want 1 decimal, 2 decimal, 3 decimal. Can you tell Python 1 decimal and the rest don't store it or anything?
So yeah, you can tell it that you only want to store the first decimal. For example, you can say make it print only up till here. So say something like that.
Yeah.
So you can make those kinds of printing. But for example, if you want to test equality up to the first decimal, you can't just do something like this. Like you have to be a bit more careful where you have to be like, okay, I'm going to test a plus b minus c, and it should be less than 0.01 or something like
So
that.
still the error rate.
Yeah, you have to say that there is some error, and you'll say, okay, I want something if they are less than this error.
Yeah.
Okay, now I want you to try out some very simple code. So basically put in like a value of Celsius here. Initialize some Celsius here. So for example, initialize Celsius to 37, our human body temperature, and compute the temperature in Fahrenheit using a formula, and then this will automatically print. The formula is up there. And if you're already done writing, I also want you to try out a quick experiment where instead of writing C into 9.5, 9 over 5, try writing C into 1.8 and checking if you get the same answer in Fahrenheit. That's the best part. Especially with all the comments and things like that, it will just automatically start.
Although in that, it didn't provide.
Are you using like, oh, we did all that?
Moved in this, I started typing in Fahrenheit and then added everything else below it.
Wow. We have to call it Celsius. So C is Celsius in this variable. Now, Fahrenheit is whatever is in Celsius times 9.9 over 5 plus 32. Yeah, so that should be Celsius because that's where there's, yeah, like a small case sensitive. So this will be
I'm trying to get help to understand this. That's instruction. So I should have written Celsius equal and whatever number is that.
yeah.
I was trying to use X equals Celsius, but that makes no sense.
No, because you have to store the temperature in Celsius instead.
I see. So Celsius is the name I give to
Yes.
whatever numbers will be the answer.
Yeah.
But I can keep changing.
Yeah.
Okay.
Trivial X equals something and then Celsius equals X.
Exactly.
And then you would have kind of done what you could.
So Celsius is not exactly equal. This so this is C into 9 over 5 plus 32, so that's the Fahrenheit part. So this Celsius is something. So this is the temperature in Celsius times 9 over 5 plus 32 is Fahrenheit. So first for Celsius, I want you to initialize to some value. So like some value, like let's say 37.
What did you want us to test?
So I want you to test, instead of doing C into 9 over 5, I want you to try C into 1.8
Uh,
and see if you get the same answer. Check whether they're the same. One. No, but I want you to check using the computer if they are the same. Not just visually. Oh, you mean like? Like store that value, Fahrenheit 1, Fahrenheit 2, store two different variables with two different formulas, and check if they're good. Similar to how I did AE plus BE equal to C. So this is not X. Can you? Yeah, so even though it looks like X, it's actually this character.
and I copy this then just change the one for me. So I wanted to generate two different prints, temperature one, temperature one,
Okay.
and then two and two, and then one, two, okay. Oh, other. Nothing is it doesn't have to feel, so I don't know. No. Then the series you create another variable file v2. Yeah. And instead of consisting line, right? Yeah. Do that I have to do number four initialize again, number five, blah blah blah, number six, temperature two and two, and then another line to compare. Or that's the no, you already initialize once in sense yes, so what happened? I see, so I perform the calculation. So I have to insert any calculation here. Yes, thank you. Oh, it doesn't show anything because you just computed them. Okay, so they are stored somewhere. But you write these, copy this part of it out, and then it will show stuff. No, this bad. This is a solution. That's still like in the computer.
Oh, ask it.
The ID
Got it.
stuff I do.
Yeah, yeah.
like I'm actually doesn't matter, right? Just not state. No, it's oh, you can't put spaces in that. Yeah, yeah. Even your space are understand. Yes. I hear by doing that connected that. I leave this here or doesn't matter. So here because the things are distinct to us. So we can time to the first thing. It is called the things like therapy involved do therapy this many of thank oh the H is missing. Thank you.
So I hope you wrote the code, and I hope you're getting a feel of how things work. So here basically you would just put in a number and then you plug in this formula, 9.9/5 into Celsius plus 32, and then it just prints you the answers. Okay. And for those of you who had time, you also tried, instead of 9/5, you tried 1.8. And what did you get? Did you get the same temperature?
It got true.
You got true?
Yeah.
So this is one of those places where floating point errors are always a mystery, right? Because sometimes you do get true. That's the answer. So even though there is a potential for floating point error. So here, sometimes you'll get true, sometimes you'll get false.
If I put print each temperature, could maybe I can see that the number is different.
Sometimes you can see the number is different. Sometimes even if it prints the same number, maybe the floating point further down there's an issue.
So that doesn't fix anything.
Yeah. So you can just try running that code multiple times with different values of Celsius, and for some it will give true, some it will give false.
Yeah, 25 is to me.
Oh yeah, 25.
17 is better. Let's see.
It's like you reinitialize each Celsius.
Yeah, this is true. C11 is in front.
Beyond that, I heard the exact same change. So should reinitialize Celsius again.
False.
You got false
For value of 26.
see.
Oh, different values.
Yeah. Or can you ask that? Nah, it's okay.
So you can actually do this where you can write a for loop and run through a bunch of
Make a
integers,
list of
make a
numbers.
list of numbers, run through all of them, and see for which it will give the same answer.
So what's the fix? If this is not
Yeah.
trustworthy?
So okay, if you want me to spoil the suspense quickly, so the fix is, so usually you test the tolerance. So the way you test the tolerance is you have some error value you have in mind. Like tolerance is say 1 e to the negative 9, okay? Like a very, very small value, okay? And then you ask, so in your case, it will be something like print f, so I don't want to use absolute value already, but so it's something along these lines. So this is still the previous example, but here you write absolute value of Fahrenheit minus Fahrenheit 2 less than tolerance, and this is the logical operation. So what this is saying is I have two variables, Fahrenheit 1 computed one way, Fahrenheit 2 computed the other way. Are they almost the same up to this much error? So that is always what you test in science.
So with Python, you'll never know that the things are exactly the same.
No.
You'll know that they are the same up to
And then-
Python.
Exactly.
Nice.
And that is always how you test as well.
is it a quirk of Python that R doesn't have or C++ doesn't have, or is every programming has the same problem?
This floating point error is a thing in every programming language. So especially when you start doing like simulations and things like that, you will always have this in mind. You'll always know that my answers are not exactly what my computer is saying they are.
And this applies only to numbers with decimal. If I have a string of DNA, for example, and I want to find,
Yeah, that is fine.
that's fine.
That's fine. String of DNA is great. There will be no errors.
It's only decimal.
Exactly. So specifically floating point. Okay, so now let's move on to this new data type called string. Okay, so this is another very useful data type. So this is where you, for example, store DNA, or at least the sequence. So what is string? So this is basically a data type that allows you to store text. Okay, and there are two main operations. One is adding a bunch of strings. Okay, so for example, here I'm adding UCLA plus space. So this is not just completely empty string. This is string with a space in it, which you cannot see, plus string of QC bio. And what you get is UCLA space QC bio. Okay. And another option is to be multiplying the string. So it copies the string. Okay. So these are the main operations. But the thing that is the most exciting about Python and is the most useful thing is what are called these F strings. Okay. So this is what you have all been asking all this time. What is this F here? Function. So it is not function. So it means it's a formatted string. Okay. So what it means is you can do all sorts of things. You can insert variables. You can call functions. You can do anything you want as long as you put these parentheses around. So here, for example, I have this name, Amelia, and her score is 95.5. And what I did, I created a new string called message. What this is it is equal to a formatted string, student, parenthesis name. So it will tell the computer, go find where the name is stored and retrieve that value and put that in here. Okay? Score on the left. So now if you try printing out this message and see what you get. Yeah. So what you will see is a very beautiful printed message. It will say student Amelia scored 95.5% on that. Okay. So it's very, very convenient. It especially allows you to create strings that are, specific to a student, specific to a patient ID, for example, and things like that. So now, for example, imagine that I was trying to, uh, let's say I was trying to deal with a lot of patient records, okay? So let's say I have patient one, patient two, patient three, patient four, and so on. And let's say I wanted to create file names, which are all different for these people, okay? So then I can use F strings very easily, where I can be like F string, patient, parenthesis, patient ID. And then whatever department they are in, for example, underscore parenthesis department. And that will create a completely new a file name string that I can use to store all their information, for example.
And if we were to write by hand, Amelia, Bedelia, each
Exactly.
one with 2 lines. But then you should have to access a database, I'm guessing.
Yes, we will basically, so here now we have only by written by hand, but later on you'll have a whole database. You will access that database and then fill in these message strings for each of the entries from the data. Yeah. So we will do that tomorrow, like once we have a list.
Now, does Python care about uppercase versus lowercase? If you have let's say, lowercase Amelia, it would not recognize it if you're searching for.
Yes. So uppercase Amelia is different from lowercase Amelia.
Yeah.
Okay. And again, even the variable names, like if I wrote small name and I call here capital NAME,
It's different.
different. Yeah, it's extremely case sensitive. And here you can see you can also do very quick things like this. So if I have radius equals 5, the area of circle is this. So here you are doing a mathematical operation inside the parenthesis. Sequence is ATGC. I maybe want everything in uppercase. Sequence in uppercase, sequence not upper. Okay, so this is again a string operation that you can use to get all everything in uppercase.
Since we're doing multiplication with decimals there, you have to put a tolerance if you're doing something in reality or.
No, so here, so you can always multiply and everything without any worries of tolerance. But when you're checking whether it's the correct value or things like that, that is when you need to have tolerance. As long as you're computing something, right? Like you're computing area, it's fine. Like you compute area. Now, if you tell me it's 3.00000001 or 3, it's fine. Like I don't have a. But for example, if you are checking if the area is 3, then do that. Then you have to be careful.
Okay.
And this is extremely important. You cannot miss the F. If you miss the F, then all of a sudden everything just falls apart. For example, x equals 10. The value is x. The only thing missing is the F here, and this will not run. And you need that F. And this is only available in Python 3.7 and higher.
Yeah.
Yes. So this formatted string is a new thing they added. And it's extremely helpful. So now I want you to try out this automated data logging. So here the goal is write your own sample ID and some temperature. Okay. Like for example, 37 is the sample ID. Temperature maybe is 273 Kelvin. And then what I want you to do is I want you to use an F string to create something like this as the file name. And then this will automatically generate that file and so on. Okay. So basically the only thing you need to fill in, just fill in some random things here and F string here. score, and then you will put sample ID. Like this is not working. I hope you had some time to check this out. So it's essentially something as simple as this. So you have some sample ID, you have some temperature, and you just have to create a string sample underscore in parentheses sample ID underscore temperature underscore parentheses temperature dot CSV.
Let's see. If I don't know what the CSV.
So Python doesn't know. That's why you have to tell it the whole file name.
Okay.
So you have to give it the whole
Oh,
name.
we're creating the
Right. So you have to tell it that we are going to have a CSV file for this patient with this ID and this temperature, and this is it. Okay. So this is a very small snippet of what people do in daily life, right? Suppose you're accessing electronic health records, assuming they're de-identified and everything. What you will be doing is essentially something like this, where you will have a for loop, which will basically do this for every patient. Okay, now is also a good time to take a break. We will come back and continue with string manipulations, and finally we'll end with if-else statements.
um
Okay, let's keep going. So with string, there are a lot of operations that one does on them. And of course, you can always, write your own functions to process the strings and so on. But Python already has very well written functions that are very efficient and so on. Okay. So it's always, so in Python, as I told you, right, it always does more things in the background than it tells you. Okay. So it's extremely important to use Python native functions for that reason. So Python native functions know what Python does in the backup, and they will try to optimize so that it tries to provide you the best possible performance. So that's why, for example, when you're cleaning strings and things like that, it's useful to use the predefined functions. So here, the first function that we will use is dot strip. So essentially, it just removes all these white spaces. Okay, it's as simple as that. So try just running this piece of code, and you'll see that the white spaces are gone.
If I were to put, let's say, G in between the parentheses, it will remove just the G's from the sequence. Raw data dot strip.
Yeah.
Line.
Uh-huh.
You put two parentheses just to denote that it's get rid of the empty space.
Right.
But if I were to put G there, it would get rid of the G. Or
So G where? So do you mean G somewhere
in the sequence you are in.
here, like this?
No. So if you write G, in the second line it says clean data equal raw data dot strip.
Mm-hmm.
And if you put that G between the parentheses, we'll get rid of the letter D from the sequence instead of the space.
Oh,
Or it will send you an error.
so it actually does nothing.
That's not so basically the two parentheses to signal that it's just
Yeah.
strip the space.
Yeah, I had never tried that before, so
That's
I
a general subtraction thing.
yeah, it's actually funny that it doesn't do anything. But yeah, like these sort of things, you should definitely like try playing around with it, because these things are very counterintuitive often. So another thing is, for example, it can count. So dot count. So this is actually a very useful function. Like I use this all the time. Just sequence dot count, and it will count all the A's in the sequence. And this is also another very useful thing where, let's say you have some list of like, in this case, I created this weird example of nucleotides, but sometimes you get a list of things and you want to like somehow concatenate them. And here you can concatenate them by hyphenating, or you can concatenate them without any space. And this is a very, very useful operation. So if I print this, you'll see. So here, the first one I get all the items of the list nicely concatenated like this with a hyphen in between, or without any concatenation like this. And one thing to always remember is so in this very specific case, you have say name equals space UCLA space. If I do name dot strip, okay, like it's not going to do anything to this new string. Okay, so you have to always reassign to tell it, okay, you have done this change, now store it again in name or somewhere else so that you will get rid of this white space. So usually for most objects, when you do things like dot something, it will modify in place, okay? And it means that it will go to this object, it will change it in that memory location. Whereas for strings, the Python does a weird thing where it will go to that location, copy it first, and then change it.
What do you have so you have the brackets in the beginning, but you have those small bracket
Oh, yeah, this is not needed.
that's not needed.
No, that's not needed. That is a typo. So this is sometimes also the issue with AI. Sometimes it creates typos that should, like, I don't even know why it created that. So to get the hang of all the string operations, I want you to try out this GC content calculator. So this is supposedly calculating the amount of, I forget what the G and the C are. I'm sorry.
Ordinal six.
Yeah, that's right. So we are basically going to calculate how much of that is there in a raw sequence. So here, this is so here is the raw DNA that I give you. So first you have to clean this sequence, okay? So you have to get rid of all the spaces. You have to get rid of all these small letters. You have to make it all uppercase, and then you'll have to count and so on. Okay? Yeah, try to just use the functions that I gave you in the beginning. Yeah. Mhm. Really need abstract within these white spaces. Yes. So here we will be also using the string. So you're basically doing the same equation with this.
So it is in the beginning. Yeah, there's no beginning, you don't have the beginning, so. Okay. And that can be an infinite string of commands, I guess. Yeah. Based. And then I just keep this new name. I just go on. Oh, no, no. So you have a unit with so now you just count in the end. We don't count in the list. Exactly. Oh. So can you think of a cool way to find the total matrices? So you can count how many G's are there, how many C's are there, how many units can there. Yeah, when you count down four, how many of them there are and add them up. So very question. Seems just like a pen. So what it does is it creates a new string which will not have these traces. But you also want these to become upper, right? Like these one G. So you basically say D and K. Next line. DNA equals linear. Question. So now it's how to fill. So how to fill this. Yeah. Can I make it in one parentheses A, comma, T, G, comma, C? That's interesting. I have never tried that, but you can try it and see if you can. So I think most of you figured out how to do this. So this is basically the code. So DNA equals raw DNA dot strip dot upper. So the first dot strip removes those spaces. Dot upper, it makes it all uppercase. And then to count G's, remember this is very case sensitive. So you have to count capital G, capital C. And then for total length, so there is already a predefined function called length. You can directly use that. But if you didn't know that, a nice cool way to do it is you count the number of A's, the number of T's, the number of C's, and number of G's, and add them all up. That will be the total length. And then the GC percentage is exactly this. Are there any questions? So string manipulation is quite straightforward. Like you just have to use many of these functions and in like a certain sequence, and you can get basically a lot of functionality. We will learn later how to write our own functions for string manipulations.
Everyone ready for the next topic? No? Okay.
Oh, the parentheses and words.
Huh?
I did parentheses with commas for classes and it didn't work.
Is in Word? Okay.
So we just, yeah.
Ready? No, okay. Okay, while others are working, for those of you uh, who want to know how badly things can go with programming. So I will tell you an interesting story. So in C++, one of the things you have to do always is you have to put a semicolon at the end of every line. Okay, every line you have to put a semicolon to tell the compiler that, hey, this is one unit of code, that is it. So you tell this to the computer. Okay. So one really interesting thing about computers is they started adding more and more non-ASCII symbols. Okay. Do you know what ASCII is?
Yeah.
Like the usual symbols, right? But they also started adding more things. One of the things they added is what is called the Greek question mark. Okay. Has anyone ever seen the Greek question mark? Yes, it looks absolutely exactly like a semicolon, except inside the computer, it has a different code than a semicolon. Okay? So, if you want to torture someone in your lab, whoever uses C++, just replace a semicolon by a Greek question mark. That is it. They will never be able to find out what's causing the problem. Okay, ready now? Okay, so now we'll basically move on to relational operators. So these are for comparisons, okay? So the first comparison we already came across, which is equals, okay? So you can ask, is 10 equal to 10? And it's true. Not equals is that symbol. Greater than, again, less than, greater than or equal to, less than or equal to, all the usual stuff, okay? And you can do this with a computer. The only thing, which is the most common mistake that most people do, is equals versus double equals. Like sometimes our brain can just not read it. Like for example, if I wrote if x equals 10, like I would never catch that. Like I would never realize that it has to be double equals. So this is something you have to be very careful about. And you can also combine a bunch of conditions, okay? So for example, you can be like, if 5 greater than 2 and 10 less than 15. Or if 5 less than 2 or 10 less than 15. Not 5 equals 5, okay? So you can add these nice things. You can compare strings. That's not so exciting. So what I want you to try now is basically fill in this code. So here we are doing a very simple exercise where you have two ants on a straight line, okay? And they have their initial, they have their position at time t equals 0 and time t equals 1. Same for the ant B. So I want you to calculate their speeds. And okay, I see here that I have filled in the code, so that was unintentional. Do you also see the code filled in, or are there dots? Can I see?
Yeah.
Oh, you do have dots. Okay, that's great. Okay, I did not. So, anyways, so basically, I want you to fill in the code. So, assume that the ants are moving at a constant speed, and you know what their positions are at time t equals 0 and time t equals 1. So calculate speed from that position and then calculate at time t equals 5 what their position will be and check if these two are going to be equal or not.
Yeah, exactly. And data. Certainly, how would you use speed as this question is this amazing details of the this speed will be this position minus this position. Then when I say the speed goes in,
Yeah.
so it's just divided by lines.
Oh yeah, yeah, what moved it? Okay, I wasn't looking.
So, oh, the general one will be, if I now I just did t equals
I see, I just did.
yeah, yeah. No, no, no. Now should I multiply by star also?
I see. As I was into the general formula, and figure out how.
Yeah, I know. You are not expected to calculate directly. So here, like for example, how do you get this to right? This two is a position one minus a position zero divided by one. And so that is the formula that it's expected to get. So yeah, formula. So that the computer calculates that. Position, it also depends on its initial plus a position zero. I
But you already calculated the speed, so you don't have to put that whole difference into it. You can do speed into pi plus c.
Okay.
I think you have most of you have the idea right. So basically you have A position 0, A position 1. From that, we can calculate speed because it's only for 1 second of time. The difference is the speed. Same for speed underscore B. And then the time target is 5. So the final position is the speed times how much time they have traveled and what their initial position is. And same for final B is speed times the target time plus the initial. And then there's an if else statement, which we'll discuss very soon. Basically, it tries to do if something is true, do something. If something else is not true, do something else. So here what happens is there is no meeting. Are there any questions before we move on to the next case? So here the main relational operator we use is this. If this is true.
What is time to target defined? Oh,
Yeah, I just defined it to be 5, but like
yeah.
we can. So I initially wanted the question a little bit more challenging, where I would just give you different x and y A position 0, A position 1, and B position 0, B position 1, and ask you what time will they ever be, if they meet. But I thought that will be too much. So for now, I just did it this way. So these two ants, you can guess, right? These two will actually meet at some point. Because the first ant is going at 2 speed, this is going at 1 speed. So in 10 seconds, they will actually meet. Oh yeah, why don't you also, if you have this code already, why don't you just change the time target to 10 and quickly check that it does show that they meet. Or now I'm wondering if there will be a floating point here. Look at these are all floats.
Yeah, they need a position 20.
It's sure it's
Yeah.
true.
Just as a true success.
Success
location.
Oh, good to know. But anyways, if there is one lesson you learned, like you don't always check this way. Okay, so
Oh, you need the
you would check with the tolerance usually.
unless you use
Yeah,
using integers.
if you use integers, then everything would have been fine.
Yeah,
But because
you put a decimal.
yeah, I put a decimal, this will automatically become float, and then it has a floating point at this.
Gemini to tell me which they would be. Wrote all the code.
Yeah. It is very good with that. Especially if you can break the task into many small tasks, AI is very good. So it's now on humans to be able to give it small enough tasks so that you conceive the bigger task and you break it into many small pieces. So now we'll finally come to the one of the last topics for today, which is if-else statements. Okay. So this is essentially controlling the logic flow. Basically, how this goes is you have this block. Okay. If some logical statement. Okay. Like how we had before. And then if that happens, under this code block will get executed. Okay. And that is it. If that is not true, then it will come here. And then check again this logical state. If it is true, this code block will get executed and that is it. If that is also false, then it will come here and execute what is here. Okay. So this is the precise order in which this happens. And that's very important. And another new thing that starts happening is until now, we haven't had to deal with what is called indentation. Okay. So in Python, how do you tell it that this is a code block and things like that? That is via indentation. So here you see this big space here. That's what's called indentation. So here, whatever you want to, so here this parenthesis tells you that there's a new code block starting. And the indentation will tell you how much of that code block is under this parenthesis. So here, for example, I did if this, print this. Okay, the print is with this space here. So that means that this is under this code block. But then elif is again moved all the way back. So this is now no longer under this code block. This is a new code block. And so on. Okay. So here what will happen? GC content is 55. So it's going to go in and be like, it will check whether this statement is true. GC content is 55. It's not greater than 60. This is false. So it will be like, that is false. I'm going to go to the next step. Elif GC content less than 40. Is it less than 40? It is not less than 40. So this is also false. So it's going to the else. And then it will be like print moderate GC content. So it will just print this moderate GC content. Does that make sense?
If you were to indent elif 4 more points past print, is that the computer doesn't care? Or
No. So if you put LF like that, it will just get confused. Because
so
how did LF come without it? So let me show you something. So So here is where it's useful to know some of these shortcuts. So if you see, it's already crying. Why is there an LF here? Okay. Yeah. But if I make it an if, see, there is no LF.
I see.
Okay, so you can have an if else if block inside an if else if block. Okay, so you can have like all these nested levels of logic. That is perfectly fine. But there has to be the first start is always an if. Without an if, you can't have an if.
Okay.
So, for instance, can you guess what the output of this function will be? Hmm?
It's the same.
Yeah, it will still be the same because
Doesn't mean either of these.
exactly. Now, suppose I do this. Can you guess what the output will be?
IGC content. IGC content.
Everyone agrees? Okay. Now, what if I do this?
It brings low GC content effect. Certified? Yeah.
Okay, let's see. How many of you think low GC content will be detected? Oh, no one else is supporting. Okay. Okay, if you have a different answer, what do you think it will be?
I mean, it doesn't comply with the first key, so it goes to the second.
Exactly. So it will still print moderate GC content because it will first check if GC content is greater than 60. It is not. So it will not go into any of this. It will directly go here and print this.
It skips a second.
It skips everything in here. It doesn't even see that there is a if there.
I see. So you cannot nest it pretty.
Exactly. In this particular case, you cannot nest it like this. If you nest it like this, you will never actually catch this condition because you only go to this if it is greater than 60.
I see.
And here you are saying if it is less than 40, it will never be less than 40.
You could put another state, then it would be a additional action take within the sequence.
Say that again.
You could have the next if they're shifted within that block,
Mhm.
And if the statement were also true, which it's not here, it would still complete that
Yes.
as well.
Yes.
So it would complete the if, it would give a high, if you got a different thing that said print something else, it would then also print that if that was correct.
Yeah. So for example, let's say you have a GC content here to be 85, okay? So here maybe I'll say if GC content greater than 80, I can be like super high GC content detected. So we know that super high can only happen when there is at least high. So here you'll see the high GC content detected, and then it goes into this if condition, and then says super high GC.
I see.
Okay.
So it has to basically, as long as it fulfills the previous condition, you can nest it forever.
Yes.
But if it misses one of them, it jumps ship.
It jumps ship, it jumps to the next possible thing of the. Okay. So now we are going to do another really interesting exercise.
And then if you wanted to
Uh-huh.
not print the high GC content, but just super high, you would say something like GC content greater than 16 and less than 8.
Exactly. So yeah, so something like this. So if you want something, something like this. Oh, sorry. I also want to quickly mention one really useful practical thing. So with Python, indentation is so important that you'll constantly be moving blocks of code around, okay? With left indenting, right indenting, and things like that. So the way to move things around easily is you first select any piece of code, okay? So here, for example, I will select this piece, okay? Let's say I want to move it by a tab, okay? So the thing to press are control and the square brackets. Do you know what I'm talking about? So yeah, control and that. So that is how you move things. So control and the closing square bracket moves it to the right. Control and open square bracket moves it to the left. Yeah. So this is one of those things that is kind of important just because of how important indentation is in Python. So are you able to move? No. So I'll just quickly show you. So suppose you want
Oh, you think you have to select the block on just
Make sure to select some codes. Okay, so for example, let's say I want to place your selection. You select this code. You think command for you. Yeah, this. You see how it's moving? Yeah. And this moves it. Yeah. Use it.
might be different on that.
It's command. Okay, and please try to use these because if you get into indentation errors, it will just screw with your mind. Like because sometimes what people do is they'll press space to indent, and that's a really bad idea because like sometimes it's not even visually obvious that they are not indented or anything like that, and then it just becomes too much. Like so, just use a more standard method of indentation.
And for a single line tabs.
Yeah, for a single line, just tab is good. But for multiple lines, use the control and this. It will automatically do whatever indentation you're already using, either spaces or tabs. It will do the exact same thing. So you'll be fine. Okay, and I think this is the last activity for today. So this is basically so one thing that we will try to build during this workshop will be like a predator-prey agent-based model. So basically what we are going to do is we are going to have shark and tuna, okay? And they are going to chase each other around, okay? So how we are going to do that? We are going to do that in multiple steps, okay? So the first step is we will first just initialize a shark to a certain location and tuna to a certain location, okay? Just one shark, one tuna. Later on, we will initialize many sharks and many tunas. But for now, one shark and one tuna. And then we will also initialize their speeds. So the initialization of the velocity is also given. So then what we are going to do next is we are going to calculate their distance. And then depending on whether that distance is, sorry, I don't want to show you the whole code already. I'll let you think a little bit. So depending on the distance threshold, either a shark detects tuna and points itself towards the tuna, and similarly, the tuna detects the shark and points itself away from the shark. Okay. And similarly, if they are completely far away, they will just go in their usual speeds. Okay. So that's the ABM. Does everyone know what an ABM is? Or oh, okay. So this is like a classic simulation, basically. So what we are doing here is a simulation of how a shark would try to prey on a tuna. Very simplistic model. So there is a shark in the ocean. It's nicely going around with its nice speed. And there's a tuna in the ocean, which is also nicely going around with its initial speed. But when they see each other, that is when they change their directions. Okay. Shark will change its direction towards the and tuna will change its direction away from it. Okay. And if they don't see each other, they just keep going down. And here what we are going to do is we will do an update for one time step. Okay, next what we will do, we will update for multiple time steps. We will then do it for multiple sharks. fill out. So I just sent you a Google form to the quiz. So please just fill out the quiz in the last 10 minutes. If you didn't get the link, please let me know. Is anyone here taking it for credit? Ah, okay. Yeah, you should try to fill it. It shouldn't take you more than. Got the link, right? Yeah. Yeah. Copy paste the no, no. Okay. You should try to. Okay. Yeah, for those taking the quiz, don't copy paste the code into a code block. Check the output. Like you're supposed to do it in your head, essentially. You are the computer now. Okay. It's like a mission courses. And use the email ID with which you registered for this class so that I know it's you. Tuna underscore x equals tuna underscore x equals. It was just a shortcut, right? So I have to rewrite tuna underscore x twice. I see. That's it. Include assurance because it was specific. So respect to the
Yeah, you know. It's that's just I didn't get only put two listeners. So this is not the so saying I will be this so I run this. You can do the learner's coach.
Suffering.
Involved in your bigger. Yeah, the two days as I was thinking.
Thank you.
Alright, so if there's made updates, I use this as each from the first year, so. Use it work with the.
Yeah,
It's also
So-
getting it right.
you agree that that's a doubt you know everything they need. The easiest way.
Yeah.
I got that.
Oh, nice. So my question is, I was at Excel here. One thing, one thing, chart. So you just reverse. The it's the but you say said so so it's proportional. So usually how we were that something like this is suppose the shark is going like this to make this. Let's say shark 6 is 2. So then what shark will do is it will compute that the direction it needs to go is this way and then turn this way. So what we would do is we will compute the position vector of theta, the position vector of shark, take the difference, and that will be the velocity direction for shark. The vector of take that vector difference. So this makes no sense. Yeah. Oh, you would also declare for credit. No, you just want to do credit risk or half.
Okay, I hope all the people who are taking it for credit took the quiz. Okay, good. So now I want to show you what happens when you blindly trust AI. Okay. So here is what AI generated. This is the AI generated code for me. Okay. So it is AI is this really fascinating tool. This can be very helpful as you are probably seeing, right? It's doing all this nice autocomplete. But it also sometimes makes ridiculous errors which make no sense. Okay. And it will do these without telling you why. Okay, so one of the things. So here, if you see this logic here, so the distance is computed correct. Okay, that's great. So now detection threshold is let's say 10. So here it says if distance less than detection threshold, then shark has to chase the tune. Okay, so how do you find which direction to chase? Well, you use this vector tuna x minus shark x, tuna y minus shark y. That will be the direction you want to chase. Okay, but now how do you figure out how exactly what is the speed with which you do? Okay, so here, what is the multiplier here? I understood the direction, but what is the multiplier? How do you figure that out? So the correct way to figure that out is first you calculate this vector, tuna x minus shark x, comma, tuna y minus shark y. So that's a vector. It's going to have a magnitude. So you have to first make it into a unit vector so that it's only a direction. And after that, oh, it's time. I closed the Zoom. Oh, okay. Oh, that actually ends it for today. Whoever is online, thank you for joining. Are you sure you want to stop recording?